Well, good afternoon and welcome everyone to the EBA webinar podcast series. We're excited today to present the RESNET Carbon Trifecta, Embracing Environmental Justice Through the Lens of Carbon Use Intensity. Throughout today's presentation, please use the Q&A section to ask questions to our panelists. We'll take those at the end of the presentation. And if you want to pass this along to a friend, it will be up at eba.org on our learning management system, as well as on the Better Homes, Better Future podcast. So let me take a brief second to introduce our audience. And next slide, Betsy. We have Nicole Berger, the Director of High Performance Buildings at Innova Building Advisors, Andy Buccino, the Manager of the Energy Division for Stevens & Company, and Jacob Deva Rakusin, the Director of Building Science and Sustainability for New Frameworks. So we're so happy to have you here. Welcome, everyone.
Thank you.
Great to be here. Thanks.
Yeah, thank you very much.
Well, Nicole, I'll turn it over to you, I believe, to kick us off.
Yes, thank you so much. The HERS Index is a rating. Oh, sorry, Betsy, can you go back? Sorry. The HERS Index can help address energy disparities by enabling consumers to reduce energy costs, improve indoor air quality, and enhance overall well-being. By combining the use of the HERS Index with broader energy labeling and decarbonization policies, it is possible to create a more equitable and sustainable energy future for all. Next, please, Betsy. RESNET is a recognized national standards making body for building energy efficiency rating and certification. The number of homes that were HERS rated and received a HERS index score in 2023 continued to break historical records. Since the last time the three of us presented, and I presented this slide, which was 5 months ago, the total number of HERS rated homes increased by over 187,000. The significant increase in HERS rated homes presents a golden opportunity to accelerate energy labeling and decarbonization efforts. Next, please. So similar to golf, the lower HERS score, the better. The HERS Index can be a powerful tool in achieving energy equity through comprehensive energy labeling and decarbonization policies. Currently, the HERS Index focuses on measuring and reducing operational emissions, B6 through B7, the operational energy, heating, cooling, and water use. Next, please. So listed on this slide are the top 10 states with the most HERS rated homes, but more importantly, according to RESNET 2023, HERS rated homes will net over $296 million in annual energy bill savings as compared to the HERS reference home. Next, please. So in addition to assisting renters and home buyers, a HERS rating is a valuable tool to identify and address disparities, helping to identify neighborhoods and communities with a disproportionate number of energy inefficient homes. So why energy labeling is important. So RMI's research reveals a significant energy burden on low-income households. These households spend a disproportionately high percentage of their income on energy compared to higher income families. This financial strain forces many to make difficult decisions, such as reducing food or medicine purchases or even enduring unsafe temperatures. So addressing this issue requires immediate action to prevent energy poverty. The current scenario demands action to bridge the gap in energy affordability by acknowledging the disproportionate burden faced by low-income households and implementing effective measures. We can work towards a future where essential energy needs are met without pushing individuals into a state of energy poverty. Next, please. So other reasons for energy labeling, right? Things aren't always what they seem. It's a nice facade, but next, please. What's hiding under that facade? Probably, most likely high utility bills, uncomfortable drafty rooms, poor indoor air quality. So we all know that HERS ratings can show what can't be seen. Next, please. And this is a letter from my landlord, and it just illustrates that human behavior significantly impacts energy consumption, much like driving habits influence fuel efficiency. So to accurately assess energy usage, transparency in monthly utility bills is crucial. While past bills offer a historical perspective, they alone cannot provide a comprehensive understanding of current consumption patterns. Next, please. As you can see, my bill didn't really line up with what was being said, but I'm not surprised because the House was drafty and uncomfortable. And I guess the bottom line is, we shouldn't solely rely upon utility bills for providing us with the energy transparency that we should be provided. Next, please. This is just a little peek inside of where the drafts were coming from. That's just to share it. Next, please. And again, I ran a HERS model, or I did some modeling in Ecotrope, and not surprised, it's 21% over the HERS reference home. So it's 21% less efficient than the HERS reference home. Next, please. This is a case comparison, why energy transparency matters, especially in historic change of use projects. So this is a comparison of an existing 100-year-old brick building with a new addition. The units are on the same floor. The only difference is the windows in the existing portion are thermally broken aluminum, while in the new addition, it's UPVC. The question I have is, who decides which tenant gets the units with the higher energy bill? Soaring energy prices are placing a heavy financial burden on many renters. The overwhelming demand for assistance programs highlights the growing need for support in this area. This situation raises concerns about whether historic limitations on energy efficiency upgrades in change of use buildings are inadvertently shifting the financial burden onto tenants. Moving forward, how can we ensure a more equitable approach to energy costs for tenants, considering both energy assistance programs and potential upgrades to improve building efficiency? Next, please. The Inflation Reduction Act and HERS ratings are directly linked through the Act's focus on energy efficiency. HERS ratings are required for consumer protection, providing homeowners a clear understanding of a home's energy performance, helping them to make informed decisions. So energy labeling homes and rentals is a critical step towards creating a more just and equitable society. And now I believe it's going to be Andy.
Thanks, Nicole. To point of clarification for Nicole, she referenced a HERS reference home, and that HERS reference home is a home built to code in 2006. So when you see a HERS 121, it's 21% less efficient than a home built in 2006. So that's kind of our benchmark, and that'll come up in the CO2 index also. Betsy, next slide, please. RESNET carbon index. So this baby is almost a year old. It rolled out of beta in Ecotrope, which is HERS Rater software, last November. We shortly thereafter presented this session for the first time. And a year later, we're just starting to understand the power of the HERS CO2 index. It's a first of its kind carbon emissions tracker. So we're taking operational carbon and tracking, operational emissions coming from residential construction and tracking the carbon that's emitted from the grid. This is an update from RESNET 301. It's an addendum that came out just last year. What's unique is that it tracks and values carbon based on time of use. So when the building is using electricity, it's quantifying the carbon that is being produced at the grid level. Next slide, please, Betsy. So with the CO2 index and standard 1550, which is the embodied carbon standard in development now, Jake will discuss that. We're now able to leverage the RESNET, what we're calling the Trifecta, operational, the CO2 index, and an embodied carbon standard, and consider a whole building life cycle analysis. And we can do that, or we'll soon be able to do that for both new and existing buildings. In this slide, you'll see operational carbon is in blue in the center, something most of us are familiar with as energy raters or energy efficiency consultants. The HERS index already does this really well. On the embodied carbon side of the equation, back in 2020, we recognized some parallels at Northeast HERS Alliance in our small embodied carbon team. There's parallels in HERS data collection, and we saw an opportunity to track embodied carbon as well. So 4 short years later, which seems like 2 decades or 1 month, depending on how you look at it, we are now doing a 100 home study in Massachusetts using Ecotrope and leveraging it with Beam software, which Jacob helped to develop also. Next slide, please. As I'll show, the CO2 index takes advantage of the NREL Cambium database. It leverages calculations of the HERS rating process and the HERS index, which calculates operational carbon. It also accounts for site combustion equipment. It tracks those emissions at the point of install. So this gives us a full picture of carbon emissions from the building's operational use. Next, please. So the idea behind this standard has been incubating for about 15 years, but up until 2020, there was no mechanism for RESNET to bring this to reality. That's when NREL's Cambium database went online in 2020. It breaks down the contiguous 48 states into 20 regions based on US EPA eGrid regions. Excuse me. Cambium quantifies CO2 emissions for each of these regions, and it's done on an hourly basis, 24 hours a day, 365 days a year. Next. Which might look something like this on any one of these grid regions. You'll see the center of this graph looks like the sun. Well, you'll see that it's also when the sun's up. On the x-axis, you'll see 6 a.m. about when the sunrise is, up until 6 p.m. when the sun sets. So you'll see a lower number there. Each of these cells is telling us kilograms of CO2 per megawatt hour of production. So that's what this chart that's what this graph charts. The y-axis is in months. Next. Okay, so here are the 20 regions in a column format. You'll notice the greener the cell, the greener the grid at that time of day. Interesting thing about Cambium is it actually plays out or games 10 different possible scenarios of energy production, from high fossil fuel content to low cost of renewables. The CO2 index uses this low renewables cost scenario. This is done because it's got the highest market share of renewable energy, as we see just an explosion of renewable energy in the marketplace. And this is also levelized over 25 years, from 2025 to 2050. And this was chosen because it tracks with the trend of a renewable energy penetration in the global market. Next. Here you'll see a snapshot of ISO New England. Of course, this is their website, and this map changes on a minute-to-minute basis. This is from, I think, last November. The time is less important than the fact that it's changed based on the time of day. So if the wind's blowing off the south shore of Nantucket, where I am, where hopefully there'll soon to be a couple hundred wind turbines making enough electricity for 1.5 million homes, then that blend of renewables will be increased here in this pie chart. Renewable penetration will change over time. So this is ISO New England, and this is what Cambium is actually mapping. So Nicole's a HERS rater, I'm a HERS rater. We do HERS rater work. Next slide, please, Betsy. And so this is an actual development that my team has been working on for a couple of years. We're closing it out now, and we're doing final testing. It's 22 units of affordable housing. And you'll see in the center of the parking, it's 121 kilowatts of solar PV parking array. So we're really excited. That's going to go online in about 6 weeks. So I'd already HERS modeled all of this. And the nice thing about the CO2 index is it's a natural byproduct of the HERS index that we've already done the work on. So it's a simple report. So I took all 22 units and put them through the CO2 index. And I also ran an embodied carbon study of them using the BEAM tool. Next slide, please, Betsy. This is one unit, one of the 22. What's interesting is you'll see a carbon index score of 41 next to a HERS index score of 40. The CO2 index uses an electric building as its baseline. So this is in close alignment with a HERS 40 by default for that reason. Next slide, please. So I took all 22 units and I ran them through the CO2 index. I wanted to understand what would happen if I move them from one region to a next, from one grid to the next. And I chose these three because of their varying intensities. New York State, you'll see, is really green there on the left. New England in the middle is kind of average in the big picture for the United States. And Ohio, Southern Ohio there, is pretty intense. It got a lot of coal there. So I took each of those regions and ran all the models through there to discover what kind of impact the different grid would have on the exact same building with all the exact equipment, same insulation values. Next slide, please. And we got some pretty interesting results. Ohio is the most intensive, so 1,200 tons of CO2 over 25 years operationally from that grid. And then New England was about 800 tons, and New York was just over 600 tons of CO2 emitted or equivalent. It's a really interesting dynamic. Makes us consider how are these buildings performing and what can we do to improve that if we're just looking at operational intensity on the grid. Next slide, please. So as I pointed out, we also have solar, and we sized the solar equivalently to the anticipated consumption in the HERS model. So we sought to zero out or net zero operationally what this development would do. This is a single unit that you're looking at on this slide above, in that above chart. You'll see 0.34 tons of CO2 equivalent. That's even though it's been zeroed out operationally with solar. And the reason for that is because the solar doesn't work at night. So we've got this residual grid intensity that's being picked up in the overnight hours. And in New England's case, and in most examples, that's picked up by natural gas or some other fossil fuel. So we still have this residual intensity around that piece. Next. And that is represented by the blue bar across the bottom. So even after we've added all that PV to the tune of about $600,000 on the install, we still have a load on the grid. And over 25 years, that's about 200 tons of CO2. To be clear, just to be transparent, we did not quantify the amount of steel ballast that was included to make the parking structure or the PV panels themselves. Jacob's work, he may discuss this later, but some of Jacob's work acknowledges the kilograms of CO2e per watt or per panel, excuse me. Next slide, please. And so the reason those residual loads are important is because we've got peaker plants that will be there for the foreseeable future to pick up these residual loads, and when the grid is most intense and demand is highest. And these are disproportionately located in areas with a large percentage of people of color and low-income residents. So by acknowledging the CO2 index and the work that happens in that model, we could start to acknowledge those loads, limit them, transition those loads through different renewables. Next slide, please. And so now we get an awful lot of information from the CO2 index and from the HERS index. And we have the ability to map upfront carbon, embodied carbon as well, which Jacob will speak to. What happens when we can paint the same kind of picture for materials production? Are there existing mechanisms that can help to disrupt materials emissions at the extraction point, in transportation, or at the production facility? I'm really happy to introduce Jacob, who's been working on this exact problem for many, many years. And he's widely considered a leader in this market. So thank you, Jacob.
Thanks, Andy. All right, so let's pick up the material side and talk about the embodied carbon part of the picture. So just to give a little bit of context here, I'm going to assume that we're not all like nearly as familiar with this concept as we are around the world of energy. So I'm going to just give a little bit of introduction around some of the terminology and frame the conversation around material emissions and embodied carbon, and then show how it relates back to the to this larger picture of a building's total carbon impact. So if you're looking at this graph here, this donut chart here on the right, the building sector is responsible for roughly 40% of global emissions. So the operations, what Andy was just talking about, is roughly 27% of that. The other balance of that is coming, 13% of global emissions are coming from just 3 ingredients in the built environment: concrete, steel, and aluminum. So just to give a sense of scale there of really how significant the material contributions are, there's a 1 point of reference. All right, next. So what does that mean for those of us in the residential space? Well, if we take an average emission of 200 kilos of carbon dioxide equivalent, and when I say, I'm going to pause for a second to define this term, the CO2E, you can see on that little left-hand arrow there, that metric, the CO2E, the E stands for equivalent. So we're looking at all greenhouse gases normalized to their equivalent impact as per a molecule of carbon dioxide. So for example, over a 100-year period of time, methane has roughly 25 to 30 times the impact of a molecule of carbon dioxide. So its CO2e value would be 25. So we've done some studies to look at what the average emissions are for residential construction in North America. If you were to multiply those emissions out, this is just for the materials, so the emissions that are released in developing the materials for those homes, you multiply that out by the amount of new low-rise residential construction in 2017. So mind you, this is 7 years ago. That's the emissions from those materials are equal to or greater the entire national emissions of many developed countries. So when you look at it on a small residence by residence basis, it may seem small, but with the rate of construction, that is just a phenomenal amount of carbon emissions that we have the opportunity to address and reduce. So again, just giving you a point of reference on scale here. Next, please. So just to give you a sense of where that number came from, this also peeks behind the veil of some of the research that we've been doing in this space. You'll see the link below for Builders for Climate Action. I do quite a lot of work with this fantastic organization that does a lot of this research, who's also developer of a tool, which I'll discuss in a moment. You can see the sort of range of emissions that come from benchmarking studies that we conducted, actually in quite a number of regions, primarily in Canada. This is looking in Toronto. And that 200 number continues to sort of surface as a rough average. So just to give a sense of, that's looking at about 500 homes. We've looked at about 800 or so homes across multiple different municipalities, and these numbers track somewhat comparably. And more of that research is starting to happen now here in the US. We'll talk a little more about that in just a minute. Okay, next, please. So I'm going to kind of state the obvious here, but do it with numbers so that it's quantified and giving some data to back up a pretty obvious pattern here, which is that if we're trying to build low emission, low carbon buildings, as per the points made earlier in this conversation, we need to not only reduce the energy load and the carbon emissions coming from that energy, but also the emissions that are coming from the materials that it takes to build these buildings. And so what we looked at here is another benchmarking study we did. We looked at a handful of different scenarios: high embodied carbon and high operational emissions, low embodied, high operational, high embodied, low operational, and surprise, surprise, it's not until you reduce in both of those categories that you get anything that even comes close to approaching a true zero carbon building. So what I want to dispel is any kind of thought or idea that, or framing that it's one or the other, or that there's some trade-offs to happen between these two categories of energy efficiency and material emissions. Nope, we need to do both and find ways to optimize for both of those. And this is what the data shows us. All right, next, please. And so looking at that visually, so my background is as an energy nerd, energy modeler, a high performance builder. That's kind of the space I came from. And so for a really long time, our whole sort of response to dealing with the climate crisis was through reducing energy. And that is still absolutely critical. Load reduction, necessary, foundational, fundamental. It's just not, we just can't stop there. It is sort of necessary but insufficient. So what the CO2 index does is, let me start at the beginning here. Looking at that glyph in the middle, is looking at the energy use intensity. The HERS index will help us to manage the energy loads in our building. The energy source emissions, that's where the CO2 index comes into play, and allows us to understand what the carbon emissions are from that energy that we're using. And what we're saying is we also need to add some of the upfront embodied carbon emissions to get a really full picture of what the carbon emissions of our buildings are. And these separate programs within the RESNET family are what help us to track these different parts of the equation, if you will. Next, please. So you saw this graph just a little while ago, this life cycle visualization from Andy. We're going to look at it again, but I'm going to break down a little more language and definition around how we think about the various time boundaries in looking at embodied carbon. So I'm going to start the top and work my way down. So you heard me use the language material carbon emissions. Another language for that is cradle to gate. That is that first block you see on the left here. It's what it takes to extract raw materials out of the ground, say iron ore, transport to a manufacturing facility, and smelt that ore into steel, or whatever other product you seek to produce. So that gate would be factory gate. That's the emissions that it takes to create different materials. If you add in what it then takes, and that sort of second from the left box there, what it takes to then transport those materials from the manufacturing facility to the construction site and build the building itself, you add those in, and now we've got the upfront embodied carbon, cradle to site, pre-operational, a bunch of different words all describing the same things, essentially the carbon footprint that our buildings carry into its operational life. So if you're thinking of the building's life beginning when you turn the keys over and it starts occupancy, I would say no. From a climate standpoint, the beginning of its life starts when you are literally harvesting the raw materials out of the ground or out of the forest. And so what's also important to note is that if we're trying to meet carbon reduction goals within the next 5 to 15 years, it is those upfront emissions that are the lion's share, the vast majority of the emissions that our buildings are releasing are coming from those materials within this near term. The buildings start their life with this plume of emissions coming from the materials. So if we're trying to meet near-term emission reduction goals, we have to address that time boundary of when the carbon is being released. That is the time value of embodied carbon. The last thing I want to just name in terms of the boundaries here are the full lifespan of the building includes everything it takes to maintain and repair and upkeep a building throughout its useful life. There's a lot of materials that can get consumed and replaced there, as well as the end-of-life conditions of deconstructing that building, demolishing it, hauling it, waste disposal. There's emissions all the way along, depending on the material. They may have a longer or shorter life. They may be less greenhouse gas chemicals released from the end of life of various materials. You put all of those together, and we're looking at full life cycle emissions, or when we talk about embodied carbon, we're generally talking about the entire entire life cycle. And so knowing those different boundary conditions is important. Andy mentioned the upcoming RESNET standard, and we are starting by looking at the material emissions. That's where we have the best data. That's generally the largest plume of emissions across the whole life cycle for the residential space. And it's where we can sort of start our process of bringing this batch of analysis into practice as raters. So we're starting with material carbon emissions with a goal ultimately of capturing the full life cycle. Okay, next, please. So how we do this and how we actually get this information, I'm giving you one example of many. It's the one that I'm most familiar with. Andy made reference to the BEAM tool. You can see the logo in the upper right there, tool that Builders for Climate Action has produced. Sort of for this expressed purpose of looking at different materials and figuring out what their emissions are with the goal of reducing the emission intensity of our materials. It looks like a spreadsheet because it is. It is a really pretty Google sheet. You can do a quick Google search for BEAM carbon tool, or you can go to the Builders for Climate Action website and download the tool for free. And the goal is to get as many people as possible using this to be able to look at what we can see here. We have a listing of within the exterior walls category at the upper left that we're showing that this is an exterior wall group of materials that we're looking at. We've got light frame steel walls and we've got wood walls that within those categories each have a number of different products broken down by their name and in the uppercase by their size, a 2x6 versus a 2x4, 16 versus 20 gauge steel framing. So it lists all these different materials organized really well by material type. And then you'll see in the quantity, it says a certain area of square footage. We've got about 2,000 square foot of wall space. And so for each of those products, you can see what the gross emissions are. It's the total emissions that were released into the atmosphere for bringing that steel stud or that wood SPF 2x6 into existence. You can select one of those products. As you can see down near the bottom, there's a check mark along that row for the 2x6. And it highlights what the net emissions are. Now, if you go a little further to the right on that same row, you'll see some green numbers that are looking at a much larger number. For that 2x6, it's a roughly 5,000. That is the amount of carbon that is stored in the photosynthesized carbon out of the atmosphere that's been stored in that 2x6 when it was a tree. Now, we're not giving immediate credit to that carbon storage because trying to track that with wood is really complicated. But there's an option if you know where that wood came from and you can ensure that it did not contribute to deforestation and followed appropriate forest management practices, so on and so forth, and you elect to give some storage credit, you could click that box all the way to the right and show a storage emission. So that just gives like a really, really, really quick view of a very simple to use sort of design aid and accounting tool for tracking the emissions of a whole host, many thousands of different materials. The data sources from which are the environmental product declarations, or essentially the environmental nutritional labels, if you will, of all these different products. So these are disclosed by the manufacturers or their trade associations for their own products. And we're simply aggregating those EPDs and putting the data into a really easy to see and easy to use tool to help make better design decisions. Next, please. So the thing I'll end on here in this section is, if you're just introducing yourself, or if you're just hearing all this for the first time, this is your first introduction to this may seem overwhelming. You also may feel like, oh my gosh, to get to zero, we have to now start building everything out of cattails and dandelion fluff. And I'm here to encourage you that yes, maybe ultimately someday that would be lovely, but that is not where we need to start. We can make phenomenal amounts of reduction very quickly using just simple substitutions and be able to make those steps on a step-by-step basis. And so here I'm looking, maybe a little bit hard to read some of the lighter colored lighting, but starting from our baseline emissions by making a handful of moves of reducing the intensity of our concrete mixes, swapping out some of the high emission plastic insulations for plant-based installations and bio-based installations, similar with some of the siding or the cladding or the flooring products. By making a bunch of simple substitution steps, we can easily reduce 75% of the material emissions of a building without substantially having to change the design or procurement systems or anything along those lines, just by making some better choices within the material categories we're already working. So just to demystify, maybe de-risk what it may be to actually start engaging in improving the profile of our materials. All right. So actually, I'm going to keep going, but we're going to go on to the next and final section here, or maybe next to final section. Look out, section 4, looking at some of the emergent methodologies here. So kind of wrapping this all together, tying this all together. So there are now over 4 million homes that are in the RESNET program going through the HERS Index. This is a scalable approach as we're looking at what it means to really leverage this work to quite a large number of projects. And so we're doing a great job as an industry in evaluating and reducing the energy emissions, the energy consumption of our buildings, the energy loads of our buildings. Now, looking at the CO2 index, right now we have some time of use accurate emissions for those energy loads that our buildings are using, and coordinates it really closely with the HERS index. So that was great. Andy was showing us what it looks like to have a HERS and a CO2 index side by each to be able to really help the communication and evaluation of what those emissions mean. So what's coming up right now on the embodied carbon side is standard 1550, which is an embodied carbon standard within the RESNET program that is currently under development. So I'm going to talk about that for just a couple of slides now. So right now, the goal of the standard, I'll start with that to formally define it, is to develop a standardized method to calculate and report the embodied carbon impact of homes. So this is, the intention here is for this to, not unlike the way Andy described the CO2 index being something that sort of scaffolds onto the HERS index to take that energy metric and turn that into an emission metric. We're looking to bring embodied carbon as another metric that a rater can evaluate for in a standard rating process to work alongside the HERS and the CO2 index reporting. So that is the goal here. It is to sort of bundle and leverage the work that's already being done within the rating community and get a little more information. And so the development of this standard has been very explicitly sort of developed with the rating community to ensure that it's not adding an enormous amount of work, and this whole additional degree of complexity is really designed to use something like 85% of the inputs that are going into an energy model can be used directly to evaluate the embodied carbon. Andy, fact check me if that number is significantly different. There we go. So we're already getting almost all the information we need. We just need a little more information and then just run the numbers. So that's what this standard is designed to do. Next, please. By taking this approach, and really the power that comes from working within the rating community here is the ability to scale this work. And that's what is very exciting, having been working in the embodied carbon space for a very long time. There's a lot of work that's being done in the architectural community, and there's life cycle assessment programs that are designed to work within 3D architectural modeling programs. There are processes happening within various engineering communities. Structural engineers, mechanical engineers have various tools and methodologies that they're working with. Infrastructure has a whole world around looking at the embodied carbon of the gajillion tons of asphalt that we are laying down onto the ground every year. We needed something for the residential market and something that organizes really effectively with the work that's already being done. And so sort of re-emphasizing the value in not just looking at embodied carbon, but doing it in such a way that it really coordinates well within this RESNET trifecta and allows us to make decisions around embodied carbon, not in isolation, looking at materials all by themselves, but to do it in concert and in more of a holistic view alongside the energy and the operational emissions, because that's where we're going to be able to make the best, most effective, optimized decisions with the least amount of friction and the least amount of cost. So that is sort of the bullet points here, kind of pointing towards the value of why it is so powerful that raters have the opportunity to evaluate for a more of a complete carbon emission profile for the buildings that they're touching. Next, please. So the last thing I'm going to talk about here, this is very emergent. I just get very excited about it, and I know that this is also tends to be a technologically literate community. So we are doing some really exciting research around the embodied carbon of mechanical, electrical, and plumbing services. So this is an area that has largely been entirely absent from all of the embodied carbon calculations because we literally just didn't have the data. So we have more and more of that data now, and since we're trying to coordinate this work within an energy framework, it is relevant to look at the equipment that is consuming a lot of this energy. And so we're really excited now to look at this. I've been doing a bunch of research in this field. A couple of really big, exciting takeaways. Refrigerant leakage is the dominant source in the global warming impact of these really high greenhouse, high global warming potential refrigerants. Their leakage is the dominant source of emissions across this category of materials. So as we continue to electrify our buildings and migrate further and further towards refrigerant-based systems, this is a really important thing for us to pay attention to. One very good example of the relationship between our energy systems and energy consumption and the embodied carbon. But there's other take-home points around here. The amount of ductwork and metal we're consuming really makes a difference. And so efficient buildings lead to efficient ductwork systems, lead to lower embodied carbon. And similar with the overall equipment, the heavier and more intensive equipment we need to have to service larger loads, the more upfront emissions there are from putting that equipment into the world and into our buildings. So efficiency pays again and again and again and again and again. And as we look at embodied carbon, we see the same benefits of load reduction that show up in all these other facets of the building, and comfort and durability and operational emissions also really impact embodied carbon emissions as well, particularly within the MEP family of materials.
My turn. I'm going to dive in. So first of all, I did not recognize that dandelion fluff had an R value. So I'm going to be cultivating that out of my backyard. I am loaded with dandelions right now. As an Italian American, I love eating dandelion greens, and now I can insulate too. So thank you, Jacob. It's good. We're checking a lot of boxes here today.
All the boxes.
We're doing a 100-home study. I mentioned that earlier, and Jacob just moved from the slide around MEP, and that's an emergent methodology in the standard. It's recognized in the standard, and Jacob's work is now integral to the standard. And in our 100-home study, we had kind of had that as a sidebar, but I just wanted to let this group know that we were just funded to be sure to include MEP carbon or materials carbon in our 100-home study. So it's a big deal for us. We're really excited. We are launching the study in just I think 6 weeks. We'll start running through an integrated software between Ecotrope and Beam, which we've been working very diligently on with Jacob's help, and a pretty kind of ninja group of guerrilla warfare people that are just crushing it, and it's really exciting. I look forward to sharing that. Maybe next year with EBA, we can come back on and give you guys the results of what we've just discovered. So I really appreciate Jacob's leadership around embodied carbon, and for acknowledging the thoughts that we had as a HERS rating industry that we may actually be able to do some serious work. And to Nicole's earlier points around scalability, RESNET's goal is to do 1 million homes a year starting in 2027. So these incremental ticks that we're looking at, 200,000 in just 5 months, and we'll do 450,000 this year, but only 350 last year. If you look at this chart that I have up right now, the blue bar is embodied carbon emissions for this 22 unit development, and each of the separate grids that embody, the CO2 Index carbon that's being tracked there. This is just 22 units, and if we can scale that to 1 million, we're doing really impactful work. And I think the goals are pretty self-evident. Next slide, please, Betsy. One of the opportunities that we have doing the 100-home study is we have a really good budget for doing some reporting. This is not that, to be clear. This is my kind of Crayola take on what some reasonable reporting could look like. The blue is the embodied carbon again, and this is the White Plains grid. So New York, super efficient compared to the other two. And you see how impactful the embodied carbon emissions are of the materials. It takes 17 years for these lines to cross. So that orange line is the incremental operational emissions from the grid over 17 years before it actually matches. So if we're looking at 2030 goals, 2035 goals, 2050 goals, you really see how impactful this upfront and materials carbon really can be in the overall picture. Next slide, please, Betsy. And when we add things like solar PV or small wind or small hydro to a development, how can we start to look at these as microgrids, add batteries? And I want to just point out that orange bar here, this is, again, I changed colors on you. I'm not a visual guy, sorry. But the orange is the embodied carbon in this example. We didn't do anything to try to lower that bar in this project. We used lots of foam, there's lots of steel, there's reasonable amount of concrete, and we're about 220 kilograms CO2e per square meter. So that's kind of right in around the average. What if we could cut that in half? But then what if we can reduce the operational carbon? What if we can make this intersection really low over 70 years? And that's what Passive House does if you do it sensitively to the materials that are in those buildings. So because of scalability is something that we've all started to talk about, we all know how to do it. Now we have to scale it, and now we have to transform the marketplace to respond to kind of these levers that we're hoping to introduce at scale in the next couple of years. I'm going to ask Nicole to close us out around environmental justice.
Sure. Thanks, Andy. So just to kind of wrap everything up, these three indices address the overall climate impact of greenhouse gas emissions at a variety of scales, building, grid, and materials, which does address environmental justice in a general way, given that there's a disproportionate impact of climate change on vulnerable populations. Next, please, Betsy. So what does it mean? So it means that utilizing these indices to inform our actions in relation to vulnerable populations can create opportunities to address the inequity of impact on multiple scales. And this ranges from the energy labeling that I talked about, creating transparency for both renters and buyers so that they have the information they need in order to decide whether they can afford a given housing opportunity, to the Equity Workforce Development Initiative that HERS is currently undertaking in the state of Massachusetts, to the new embodied carbon standard that's currently being written, and zooming all the way out to the 30,000-foot view to remember that global conflict centered on energy resources and the associated refugee and the associated refugee crisis also have something to do with the domestic energy demand. The greater the load that the affluent place on the grid, the greater load of pollution that people of color and low-income communities bear, both at home and abroad, which is one way that the costs are externalized to those who can least afford it. Next, please. So reducing the load, one obvious step is to tighten our existing buildings. And transitioning over to renewables may be part of the solution, but renewables also raise questions about environmental justice in relation to the consequences for inhabitants of the global South, who also bear the burden of our environmental choices. Next, please. Frontline island communities are literally facing rising tides of climate change. Next, please. And despite the fact that indigenous populations, which comprise about 5% of the world's entire population, are the ones who have managed to preserve as much as 80% of the world's biodiversity, we're being asked to stop externalizing the cost, but what does that actually mean? Next, please. So part of the answer has to do with moving away from the linear process of extraction. Next, please. And begin to find ways to bend the line and close the loop by incorporating regenerative principles into our buildings, neighborhoods, and communities. Next, please. And this is where folks like Jacob are developing systems which start to have synergistic effects, where waste products from agriculture, such as straw, or lumber yards like wood chips, are diverted from the landfill and are used to create straw panels or fiberboard as insulation for homes. These products are bio-based and therefore reduce the embodied carbon footprint of the building because they sequester carbon. They also reduce the operational emissions by reducing the heating and cooling load, which also reduces the load on the grid, especially as we move towards electrification. They support local industries by creating new markets and jobs, and the building components themselves are non-toxic, making the indoor air quality far better for occupants, and it's a win-win-win for everybody. Next, please. So we're standing at quite possibly the most important crossroads in human history, where we get to decide if we will stick to familiar pathways of extraction and depletion or step forward into something new, into a world of abundance. Through the trifecta, we now have the opportunity to manage the operational, grid, and embodied impact of our buildings, which will result in both reducing the likelihood of climate-caused catastrophe as well as enhancing our building's ability to weather those events, all of which helps reduce the impact of previously externalized costs, both at home and abroad, and helps shift us in a new direction towards regeneration and resiliency. We're honored to be part of figuring this out. Thank you.
Great. Thanks so much to our panel. Maybe the first question, we've got a group of raters on, is do you think that it seems like the raters are the natural people to do these additional certifications for builders? That being said, what would the added cost be for a builder who's currently doing a HERS score, maybe doing zero energy ready home, the Mass Saves program, something like that, to add on these additional certifications for a house that they're building? Or do we not know yet? Is it too early?
Yeah. No, it's not. That's been a real driver behind the development of Standard 1550. And so looking at what those extra lifts are has actually been my responsibility on the technical committee, or part of my team's responsibility on the technical committee. And also, we had the fortune of doing the 100 home study development simultaneously that 1550 was being evolved. So we got to see, I've trained a few raters already in this integration and recognized what we already do as raters, what the extra lifts are. And the goal is to simplify so that the outputs can be nearly as clean as the CO2 index. So the CO2 index is just a report. So as Jacob said, we're trying to capture 80 to 85%, and it might be 70 in many examples. There is going to be a workflow lift. What we're discovering already in early tests is that it could be anywhere from 30 minutes extra to an hour and a half to 2, depending on the complexities of the job. And then, of course, if you scale it and you're doing a 10,000 square foot monster, it could be 4 or 5 hours of extra work. But I would say on the average, we're at 90 minutes or less. And I'd like to think that we can cut it to 60 once the tools are developed, and once I think the industry averages and standards start to get integrated into softwares, we'll see a really easy lift. Of course, it's work, yes, but it is super value added. And I hope we expressed why that is.
Andy, we've talked about specific tools here today. Obviously, there's a multitude of tools. FIAS has tools for doing the carbon footprint. The EC3 tool and Tally actually has a great system whereby if you had a digital twin of your project, you could put that in and it would be fairly automated. Have any of you checked out some of those other tools? And by the way, EBA was a financial supporter of the Beam tool to help make it free in its early days. So we're huge proponents of that. But can you talk about or experience with some of the other tools? Because I think there are a lot of good ones out there, and it might not be the end all be all for everyone.
Absolutely. I'll take a crack at that, and then Andy and
you.
Nicole, feel free to jump in. So I'm a strong proponent of what I call a tool stack, which is having a number of tools that are doing the right thing at the right time for the right job. So just using some of the examples you mentioned, EC3 or Tally, actually, let's look at that as a great example. So I often use both Beam and Tally
Right.
over the course of a given, when I'm doing consultant work on a design project, where if we're trying to make some early phase decisions on a project where the BIM model hasn't been fully developed out, that actually might be a good job for a tool like Epic. If I'm trying to make a decision really early in the planning stage, if we're in like pre-design, there are like there's a whole other series of tools. The CARE tool is another one that's really good to evaluate the impacts of preserving adaptive reuse of an existing building versus the tear down and new construction. So those tools may be super useful right at the beginning of a design process to answer very specific questions where these other tools would be useless. When I'm in the middle of design development and I'm trying to work with a team to find like the right sort of palette of materials to use, I can get those answers in Beam in under an hour, and I don't have to engage with a BIM technician or a modeling technician or anyone else in the architectural team. I can do those really quick comparative analysis studies. But then when it's time to look at the full life cycle impact of the building, and I really need to get the full picture, maybe use that for reporting or for sort of certification process, Tally's the right job for that. And so I think what's super exciting about this work is that we've got a diversity of different tools to answer different questions at different times. And just to be really clear, I guess clear on two things. One thing I just neglected to mention that I wanted to be very clear in describing the 1550 standard. It has not yet been adopted. So just to be extra clear, it is in the process right now of being adopted. We are very much hoping that it moves through that process and can actually be brought out into the world. We developed the standard explicitly so that a diversity of different tool providers could respond to that and be able to produce 1550 compliant results. So it's very tool agnostic. I just want to make it very clear that my references to Beam are largely because of my familiarity with the tool and because of that tool happens to coordinate well for the rating community and with the type of material evaluation that we're looking to do, but that no means excludes other tool providers from being able to provide comparable services and meet the needs of the standard as well.
Great.
And I guess I can chime in. I participated in the Mass CEC, the Embodied Carbon Challenge, and was introduced to a lot of different tools. And I found that one click, and I gravitated towards one click as well as
the tool called One Click LCA for those of you.
Yeah, so yeah. And also used Beam because I could look at Beam and get very quick results and then take that and look at one click. But then my other team members preferred Tally because they could take their Revit and right. I guess it's a plugin or whatever. So it was really interesting to use all these different tools. So it depends on what I need and how fast I need the turnaround is what I'm going to use. But there's such there's a plethora of great tools out there.
Yeah, that's great advice. And again, I think it goes back to the point that most smaller home builders across North America are going to lean on their energy raters to conduct some of these analysis for them. And then if I can be so bold as to say, this is the 501 course in home building, right? But this is the challenge that we all face going into this future. But I think the thing to start to think about and where to lean on your energy rater or lean on consultants is thoughtfully selecting materials, because I think it's amazing. I've spent a lot of time with Doug Terry, who you guys know as well. And he's like, I was amazed that if I just went through and kind of thoughtfully selected the insulation board I was using and thoughtfully selected, you can really significantly reduce your embodied carbon. Thoughts from the panel?
I'm going to add one really important comment to that. And I know I've been taking some airtime, so I'll let other people speak. And you can do it without having to add a lot of cost. That's a really exciting part of this, particularly those of us that are starting from having not thought of this at all. Oh my gosh, the amount of not only low-hanging fruit, but apples were just stomping around on the ground. Like there's just so much immediate improvement we can make that doesn't need to have a significant cost burden. As you start getting further and further along into some of the more like hero or specialty materials, there may be a cost burden that may be incremental or may be significant. There's also a lot of design level changes that you can make like, suffice to say, if you simplify the form of your building, you make it cheaper to build while also making it easier to make it energy efficient, while also reducing the amount of material consumption and material emissions. That's one of those like win-win-win-win-win sorts of strategies.
Yeah,
So everything you said, I'm like, couldn't agree with more. And also, it doesn't have to cost you extra money to be able to do it.
right. I'd like to ask the panel about environmental product declarations because I think it's a fascinating subject. And I think we're in a world where your carbon footprint could actually get worse before it gets better. And I want to bring up MEP in particular because I love the work you're doing on the refrigerant impact of MEP. But I think it's interesting that it's it's almost impossible for me to get an EPD on an MEP product that goes into one of my houses today. So can you maybe just expound on that as a panel a little bit of where you see things going over the next several years?
Yeah, for sure. You're bang on. The availability of quality data for that equipment is like 5 to 10 years behind the other
Right.
products we see.
Right.
And good reason. Like, it makes sense. You think about how many ingredients go into a fiberglass bat versus how many go into a heat pump, and like, oh boy, that is non-trivial to categorize that. Let alone the fact that those manufacturers are getting from a bunch of different supply vendors and they're changing, somewhat rapidly. So it's hard, and I have a lot of sympathy for the manufacturers and the challenges they face in getting good data out there. So the research I've done is there are some really good domestic EPDs and some things like wiring and piping and some of the sort of single ingredient and simple materials. So that's like exponentially developing. There's been a bunch of funding from the IRA that
That's
is
right.
going directly towards encouraging manufacturers to develop EPDs. So there's a lot of technical and financial support for manufacturers to get caught up so we can have the information we need. And there's a ton of leadership being done. I would say most thoroughly in Europe, where it has been required for manufacturers to disclose this information. Certainly in France, as well as in Germany and other
Germany.
places in the
Yeah.
EU. So there is a starting point for data. And I'd say a lot of the research for the more complex equipment that I'm working with is largely coming out of Europe right now. It's not the quality we need, and it needs
Yeah.
to improve, but that is happening rapidly. And we have got enough information to look at a general pattern and be like, yep, this is better than that. This is a thing we should avoid. This is a thing we can. We've got that level of information, and it's only going to get better in the years to come.
That's right.
Yeah, could I just
Yeah,
add?
please, Sandy.
It's actually not an ad. It's a sideways, but it's an important point I wanted to mention. And I can't believe I'm going to say this, but I want to kind of ground the discussion a little bit, and that's not my style because this has been kind of like a dream getting this rolling. This has been really amazing, and we're chasing something that's not been done before. It's really exciting. But you made an earlier point, Aaron, to leaning on your rater and leaning on that energy efficiency expert that is really being asked to do something a little bit outside of what our comfort zone is. But to that point, probably only 10% of builders, maybe 20, let's call it 30 even, are really giving attention to even the operational side and choosing equipment and doing that at a really high level. So now we're adding another layer. So I want to acknowledge that workforce development and training and scaling the teams that are going to do this work is really, in my mind, one of the critical hinges to get this right. Because if, say, we got 24 months from today, where suddenly we've got this marketplace, we've got an awful lot of work to do to go from, I think, 4,500 raters in the country that are doing 350,000 homes to how many are going to do 1 million, and then how many are going to do CO2, embodied carbon. So I really like the position of this trifecta and using it as a tool for cities, states, potentially to really focus on an existing infrastructure, drill down on it, build it out, and make it more robust than it is today. So I'm counting on the work that Betsy's doing at Northeast HERS Alliance to do that workforce development. It's really interesting. And IRA, thank you. I'm hoping that there's more funds coming. We got to keep it rolling.
Yeah, and this is like if you ever took a course on economics or macroeconomics in college or graduate school, and oh, you did really good. It's like it's time to take another course on operational and embodied carbon because we're just scratching the surface here. But I would encourage you. We have a new course called Net Zero Carbon Building Professional that EBA developed with some underwriting by USDA and ThinkWood and the Softwood Lumber Board. Encourage you to take a course like that. There's a lot of great coursework out there available, but learn more about it. Learn how to make some thoughtful decisions on the products that you use. And again, hopefully at no cost. I want to bring it maybe for a closing topic, and we had quite a few comments from our audience about and I think I know the answer to this, but why HERS? There's like, okay, it's HERS, there's HAS, there's ERI, there's a lot of different great tools available in the rating world too. And I'm sure you all have rated things to HERS or HAS or ERI or Passive House or whatever it might be. But can you just talk about, where we are today and why this initiative has maybe been led by RESNET thus far? Or is this the third rail? Anybody want to take it?
It's a tough one.
Yeah.
How about marketing? I don't know. Let's talk about scale. I think there's no easy. I haven't experienced a simpler tool. I was BPI for a number of years, and to get comprehensive reporting for under a couple $1,000s is really challenging.
Yeah.
So in my mind, the HERS platform, again, going back to boxes, checks a lot of boxes. It's not comprehensive. We can say that with good confidence. It's 85 to 90% of the rule on the operational side. It's just a snapshot, and we need to acknowledge that. But if you want to get into kind of next level work, raters are kind of in parallel with Passive House, with FIAS. We already are raters in FIAS work. So
right.
You can go to that next layer, but we're getting really good baseline information for 350, 400, a million homes a year. So let's start there. We always want to improve. Continuous improvement is kind of the nature of RESNET. And so the embodied carbon standard, once it's live, will do that. So will the Rater platform continue to be that way operationally. So I think, we need to acknowledge the frailties or shortcomings of any program, but at least acknowledge and really work towards taking advantage of the good. Nothing's perfect. We could spend another 10 grand, get a more robust model, but that's a smaller slice of what the market can afford. So I think I like where RESNET's positioned.
Yeah. Other thoughts from anyone? Yeah. Jacob.
I think that so I'm also come from a BPI background. I'm not a HERS rater. I've not been deep inside the RESNET world, so I'm actually relatively new to the community. I'm really impressed by the vision and leadership of the community and wanting to tackle not just energy and stay formally within an energy box, but really look at climate impact. I see FIAS as an organization being another organization that is sort of committed to expanding the boundaries and scope of what we're taking responsibility for as an industry, and then have the opportunity to improve upon. And so I would say, that would be my ultimate goal, would be for any of these organizations that are sort of invested in not just holding a narrow scope and boundary around energy, not that that is an inherently bad thing, but for an organization that's committed to seeing energy as part of a larger, impact category or sort of value chain, if you will, there's just a lot more opportunity. I think that's the thing I get really excited about coming from energy background, looking at embodied carbon and seeing, particularly in the MEP space, there's just so much opportunity that comes in optimizing, making one move or making one design decision that has this bank of different benefits. I think that's something we've been talking about forever in the energy community, that the same moves that reduce your energy loads also improve your comfort, also improve durability of the home, they improve your indoor air quality, like air sealing, that kind of framing. If we can just take that same pattern and amplify that out, looking at broader social and ecological impacts that also have all these direct and immediate benefits into the home, I think that rating and certification systems have a really, really powerful role to play in making that transparent and accountable and communicating that well. And so I think RESNET's got a good jump out of the gate on this for sure. And I could see the other organizations that come on along. It's necessary. Yeah. There's a market drive for it. There's some, reporting and regulatory requirements for it, We're only going to see more of this. There's only more embodied carbon work coming into policy space. I would love to see the rater communities and certification agencies really taking lead on this, and not just having it rarefied within RESNET, but seeing that as an industry level approach and business opportunity and responsibility.
Right. Just a couple quick questions. So, Andy, is it possible for me to get a CO2 index of 0 on a house that's grid connected, or does it have to be off grid to be able to get a CO2 index 0?
You can add, you can hear me. Yeah, you can add enough solar to kind of counterbalance that on a
So
reporting
if I had
side.
if I have a 0 net energy home, I could get a CO2 index of 0.
You could.
Okay.
You could. Yeah, we haven't started playing around with batteries and how those impact. I haven't,
Yeah.
and we don't account for batteries in the ResNet standard yet.
Right.
But
Yeah. I wondered
when when that happens, that'll be an interesting shift to the time of use dynamic and
Yeah.
grid connectivity and so on.
Well, that's a great. I'd love to follow up on that if I could, Andy. Is there movement within some of these panels that you've seen in ResNet for accounting for battery storage?
I've heard kind of back channel discussions about it. I don't know how close to reality that is. I think the market would need to evolve to be kind of a driver for ResNet to shift to it. Like embodied carbon is a good example. There's a huge demand for it, right? So once that is in place for batteries and we can start to acknowledge it, maybe 5 years, maybe 3, to guess, but I can see it coming up quick. There's not a lot left on the operational side for us to track.
Awesome. Well, just a final plug. Thank you so much to the panel. But if you have a house that is under construction or finished with construction, and you are a builder and you want to apply, we do have an Excellence in Decarbonization Award at this year's EBA Summit. Actually, Chris Magwood will be presenting the award. It's sponsored by our great friends at RMI and, of course, Builders for Climate Action. So we would love to get these great examples that we're starting to see pop up across the country and really shine a spotlight on those at the EBA Summit on October 2nd and 3rd in Salt Lake City. So again, this will be available at eba.org in our learning management system and our Better Homes, Better Future podcast. But from all of us at EBA, I want to thank Nicole and Andy and Jacob for being here today. And boy, I would love to have you all back because I think we've just scratched the surface today.
Yeah, thank you so much.
Thank you so much.
Great. Thanks so much, everyone.
See you at the summit. Bye.